Right, EG5. A certain type of lizard is known to have a mean mass of 72.7 grams with a standard deviation of 4.8 grams. The zoologist finds a colony of lizards in a remote place and is not sure whether they are of the same type. In order to test this, she collects a sample of 12 lizards and weighs them with the following results. Write down in precise form the zoologist's null and alternative hypotheses and state whether a one-tail or two-tail test is appropriate. Okay, so let's set up our distributions first of all. So if we define our random variable as m for mass, so m is the random variable, the mass of a randomly selected lizard. So the parent population would be normally distributed with a mass of 72.7 and a standard deviation of 4.8. And then for our sample mean population, m bar would be normally distributed with a mean of 72.7 and the standard deviation would be 4.8 over the square root of 12. So that's the variable, the standard deviation 4.8 over root 12. And then our calculated mean takes us back to key stage 3 where we have to work out the mean of 12 items of data. So we can add all of those up, but let's make use of more functions on our snazzy calculator. So if we go to statistics and one variable, it gives us a list, a sort of one column of a spreadsheet in which to enter our data. So 80.4, 67.2, 74.9, 78.8, 76.5, 75.5, 80.2, 81.9, 79.3, 70, 69.2, 69.1. So why is that better? Well, I can see straight away that I've entered 12 items of data, so I haven't got to worry that I've missed one out as I'm entering those. To then work out to get the calculator to tell us what the statistics are for those single variable data items, we press AC. It takes us to a window, statistics one variable, and then we press the options button and we want to select one variable calculations, and you can see there a nice long list of standard statistical results for that list of data. I'm interested in X bar, which is the first one, so my calculated mean M bar is going to be 75.25. Okay, so that gives me all the information I need now to answer this question or to perform the test. So the first thing they want us to do is to write down the null and alternative hypotheses. The null hypothesis is that the mean is the same, so 72.7, and what that would mean is that the lizards that she's found are of the same type. And then when we look at here and we the information that we're given and we are considering what sort of alternative hypothesis we have here, this is one where it's not suggesting that they're a heavier sample or a lighter sample. They're just different. So this is now an example of a two-tailed test where we're just saying that our alternative hypothesis is that the lizards are different and their masses are different. So the lizards would then be of a different type. So this time we have a two-tailed test, and if we have a two-tailed test at a 5% significance level, then that means that we consider half of that significance at the lower end of the tail and half of it at the higher end of the tail. So 2.5% each tail. They're giving us a significance level, so I got a free choice of methods. So for these examples I'm going to work with both. So first of all, the p-value. So what we have here is a mean of 72.7, a bell curve, and if we wanted to consider the lower end, then what we'd be looking for is, sorry, we're working with the upper end, aren't we? Because the mean that we've calculated is up here. So that's one region, the lower region. This is the upper tail, and that's going to have a calculated mean of 75.25. And I want to know what the probability is of that mean being greater than 75.25. So the p-value is the probability that the mean is greater than 75.25, and that works out to be, so we're going to go menu, I need to get out of here first, menu 7 for normal, normal cumulative, lower 75.25, upper 1 times 10 to the 99. Standard deviation is going to be 4.8 over square root of 12, and the mean is 72.7, so that works out to be 0.033. We have got a significance level of 2.5%. So our p-value is greater so it's outside the range of significance, so we write therefore not enough evidence to reject there's not enough evidence to reject the null hypothesis, which suggests the found lizards are the same as the known. So there's not enough evidence to reject the null hypothesis because the p-value is outside the level of significance. If we went method 2, what we're interested in then is this region is going to be 0.025. What value of mean mass is going to create that critical region? So on the calculator, back into 7, this time we're going inverse normal. We've got a critical region of 0.025, which gives me that as 69.98. Done it again. How many times am I going to do this evening? I don't get that off my calculator. I get 1 minus 0.25 on my calculator. Again, the alarm bells ring when that value is lower than the mean. So go back in, inverse normal, area of 1 minus 0.025. That's better. 75.42. So for the critical region, the mean has to be greater than 75.42. My calculated mean is 75.25. Therefore, outside critical region. So outside the critical region, reject H1. We're rejecting the alternative hypothesis. So that's part 2. Part 3, would your conclusion have been the same at the 10% significance level? So if I come down in this little box here for part 3, at the 10% level of significance, each tail we'd be comparing with 5%, and if we were comparing with 5%, then that would fall within it, or we'd have a different value there. So at 10% sig level, 5% each tail, our p-value is less than 0.05, therefore H0 would have been rejected. So that was the 5th example.